Let's discuss the thermodynamics of symport of sodium and glucose into the intestinal epithelial cell. As you can see, sodium on the outside of the cell is 145 millimolar and it goes down to 20, which is a favorable gradient for facilitated diffusion, but glucose goes up its concentration gradient from 2 to 8 millimolar. And since these are symported, which means they're moving in the same direction, we need to know whether this unfavorable gradient can be offset by this favorable gradient. So when we want to know if this transport is favorable, we need to set up our transport free energy equation. And recall that in this case we have two contributions. Our RT ln of Q is our concentration gradient piece. And then we also have to tack on the ZF delta psi, which is the electrostatic contribution. And the electrostatic contribution comes from the sodium going down its concentration gradient. So if we start plugging some numbers in, we're going to end up with our RT, 8.315 times 10 to the negative third kilojoules per mole Kelvin. And we're at 310 here. And our natural log of our reaction quotient. Remember, products over reactants, so sodium times glucose on the inside. All over sodium on the outside. Times glucose on the outside. And then we have to add our electrostatic contribution. In this case, our Z is 1, because that's the charge on our sodium ion. And it's always going to be scaled by Faraday's constant. But now we have to decide what delta psi is. And we can see the electrostatic potential, or the membrane potential here, the 75 millivolts with negative on the inside. A sodium coming into a negative environment will be a favorable gain of electrostatic potential, so we're going to add the negative 0.075 volts. So filling in a few simplifications, 2.577 is our RT. We'll multiply that by the log of our natural log of our concentration gradient, which is sodium on the outside is 20 times 10 to the negative 3 molar, times glucose, which is on the inside, 8 times 10 to the negative 3 molar, all over sodium on the outside, 145 times 10 to the negative 3 molar, times 2 times 10 to the negative 3 molar, which is our glucose on the outside. And then we have ZF delta psi, and that simplifies to negative 7.2375. All of this together, as the concentration gradient, contributes 1.532 kilojoules per mole to the transport, which is favorable. And then the electrostatics contribute 7.2375 kilojoules per mole to the transport. So altogether we end up with negative 8.77 kilojoules per mole. The sign tells you if it's favorable or not, and negative sign means yes, this is a favorable transport.